This module will cover the Cisco SD-WAN product line and highlight what hardware and software supports Cisco SD-WAN based on the overall role in the fabric. Upon completing this module, you should be able to highlight the existing and new product offerings that are supported as part of the Cisco SD-WAN solution, explain the key components of the Cisco SD-WAN vEdge routers, position the appropriate hardware and software based on the Cisco SD-WAN component roles and responsibilities, and describe the delivery methods for the Cisco SD-WAN controllers. The Cisco SD-WAN solution consists of 4 distinct elements. These elements are the Cisco vBond, Cisco vSmart, Cisco vManage, and Cisco vEdge. The Cisco vBond element operates at the orchestration plane. It facilitates control and management plane connectivity in the overlay. vEdge routers learn about vSmart and vManage IP address and port information from vBond upon authentication across a publicly reachable IP address. vSmart and vManage learn about the vEdge router information once authentication is successful. Once vBond has distributed this information across the control plane and connectivity plane to the vEdge routers can be established, and the vEdge routers can then disconnect from vBond. The Cisco vSmart element operates at the control plane. vSmart disseminates control plane information between vEdge, enabling data plane connectivity between vEdge routers and the network. vSmart is also responsible for distributing data plane and app-aware routing policies to the vEdge routers. It also implements control plane policies such as service chaining, multi-topology, and multi-hop. The data plane consists of the Cisco vEdge routers. vEdge routers come in physical or virtual form factors. They are responsible for providing secure data plane connectivity with other vEdge routers, establishing secure and control plane connectivity with vSmart controllers, and secure management plane connectivity with vManage. Data plane policies received from vSmarts are implemented and enforced by the vEdge routers. Routing prefixes are learned and disseminated throughout the network via traditional routing protocols such as OSPF and BGP, as well as the Cisco Overlay Management Protocol, OMP, which is responsible for control plane information sharing, which includes routing prefixes learned. Zero-touch deployment is supported by the vEdge router, which enables easy deployment as well as automatic enforcement of software versioning as devices enter the network. The management plane consists of the Cisco vManage element. This is responsible for day 0, day 1, and day 2 operations. Policies and device templates are centrally provisioned from the vSmart GUI, which includes support for roles-based access control and integration to traditional network authentication tools such as Radius and TACACS. Troubleshooting and monitoring is available from vManage dashboard, as well as greatly simplifying device software upgrades across the network. A full set of RESTful APIs are available through vManage, as well as netconf, SNMP, syslog, and IPFix. Cisco's portfolio of physical and virtual vEdge routers offer the foundational platform for running the Cisco SD-WAN solution. Cisco's vEdge 100 family offers 100 megabits per second of encrypted throughput with options for integrated 4G LTE and Wi-Fi. It fits well in the smaller branch office environments. The Cisco vEdge 1000 offers 1 gigabit per second of encrypted throughput, and it fits well in branch office or campus environments. The Cisco vEdge 2000 offers 1 to 10 gig of encrypted throughput, and it fits well in larger campus locations and data center environments. Cisco's vEdge 5000 offers north of 20 gigabits per second of encrypted throughput. It fits well in even larger campus and data center environments. As mentioned, the Cisco vEdge routers can be offered in a virtual form factor, in which case it's called a vEdge cloud. The vEdge cloud can be delivered on gray box or white box x86 platforms for private cloud on-prem deployment. It is supported on ESXi and KVM hypervisors. Its performance is derived from the amount of allocated resources. The vEdge cloud can also be deployed in public cloud environments, such as AWS or Microsoft Azure. In that case as well, its performance is derived from the amount of allocated resources. Taking a little bit of a deeper look into the characteristics of the Cisco vEdge 100 family line, this family consists of 3 models. There's an Ethernet-only model, a 4G LTE only, and a 4G LTE plus Wi-Fi model. They all come with 5 10-100 1000 based copper ports. The vEdge 1000 and 2000 routers are displayed here. The vEdge 1000 has 8 10-100 1000 SFP based ports and can leverage 3G or 4G via the USB port or via Ethernet handoff from a 4G modem. It has dual external power supplies. The vEdge 2000 router is targeted at large remote sites and data center locations, and it has 4 10-100 1000 SFP-based ports on board and supports 2 pluggable interface modules, which enables additional 1 gig or 10 gig interface options. Available PIMs include an 8-port 10-100 1000 SFP card and a 2-port 10 gig SFP Plus card. 3G and 4G can also be available to this device via USB or an Ethernet LTE modem. And finally, let's look at the high-level characteristics of the highest performing router, the Cisco vEdge 5000. There are 4 NIM slots on this platform, which can house a variety of 1 gig, 10 gig, or 40 gig port types. Cisco's vEdge Cloud Virtual Router offers the ability to provision the Cisco SD-WAN solution in a virtual environment. For on-prem deployments, vEdge Cloud can run as a VM on ESXi and KVM hypervisors, and it can be deployed on any x86 server. In this case, vEdge Cloud can act as NFV in a virtual branch that can act as a VNF within that NFV platform. And Cisco's vEdge Cloud can also be used to extend the Cisco SD-WAN fabric into the public infrastructure as a service environments such as Amazon Web Services and Microsoft Azure. In this case, the vEdge Cloud is delivered as a virtual machine instantiated in AWS VPCs or Microsoft Azure VNet. Cisco's vEdge Cloud throughput is dependent on the amount of allocated resources, more specifically the number of vCPUs. Tested performance numbers for the Cisco vEdge Cloud range from hundreds of megabits per second to over a gigabit per second of throughput. Cisco's SD-WAN is a cloud-delivered and cloud-operated solution for both public and private clouds. When deployed in a private cloud, all orchestration, control, and management elements are deployed in a customer's private data center or data centers. ESXi and KVM are the 2 most common and supported hypervisors. vBond Orchestrator can be deployed as a vEdge Cloud instance with activated vBond process. vManage is deployed as a virtual machine, and vSmart controllers can be deployed as either a virtual machine or containers. Container deployment is done using vContainer image within Docker. Similarly, for public cloud deployments, vBond, vManage, and vSmart are deployed as virtual machines in AWS or Microsoft Azure, while vSmart also can be deployed as a container within these environments using a vContainer image. In summary, in this module, you learned how to highlight the existing and new product offerings that are supported as part of the Cisco SD-WAN solution, explain the key components of the Cisco SD-WAN vEdge routers, position the appropriate hardware and software based on the Cisco SD-WAN component roles and responsibilities, and describe delivery methods for the Cisco SD-WAN controllers. This concludes the products module. Thank you for watching.